New England forests are often seen as allies in our fight against climate change by storing large amounts of carbon both below ground and in vegetation, carbon which would otherwise be loose in our atmosphere as carbon dioxide. But what happens when these forests are exposed to extreme weather events, such as hurricanes? We know that hurricanes cause immense damage above ground, with tree fall disturbing our soils and adding massive inputs of decaying wood atop our soils. And this creates the perfect storm below ground in our soils with increased carbon and moisture inputs. This likely causes the formation of soil anoxic microsites. Soil anoxic microsites are small oxygen-depleted pockets in soils which can be considered climate wildcards. While anoxic microsites can trap and protect carbon in our soils, they're also able to produce harmful greenhouse gases such as methane and nitrous oxide, which are far more potent in warming our atmosphere than carbon dioxide. However, we currently know very little about how anoxic microsites form, where they form, and the overall impact to our soils and the atmosphere. And that's where my research comes in. My work aims to map the abundance, distribution, and overall impact of soil anoxic microsites. And to do so, I utilize a hurricane simulation plot at the Harvard Forest in Massachusetts to assess how hurricanes are impacting our soils. So in the field, I take soil samples beneath felled trees in search of anoxic microsites. Additionally, I take soil greenhouse gas samples in the field and measuring the relative amounts of carbon dioxide, methane, and nitrous oxide coming off of our soils. And with my soil samples, I do a bunch of laboratory analyses looking at microbial communities, oxygen depletions, and soil nutrient profiles in order to pinpoint exactly where anoxic microsites are forming. And by measuring gases such as methane and nitrous oxide, I can see if their increased emissions are correlated with the presence of soil anoxic microsites. And as extreme weather events are becoming far more intense and severe in their nature, it is essential to understand how such disturbances are impacting our soils and our forests. If anoxic microsites are widespread, our climate models are currently underestimating the carbon stored below ground in addition to the gases coming off of our soils. So this is why it's so important to understand and unlock the mysteries of the soil anoxic microsite in order to not only adjust our current climate models, but also adjust how we are protecting and managing our forests as our climate is becoming increasingly unpredictable in nature. Thank you.